Okay, this is our section 4.3, number 8. Calculators are allowed, though again they aren't going to help you. And if we look here, it says I want to find the intervals in which the function whose derivatives are shown are increasing and decreasing. So I want to know when the original function has a positive slope and a negative slope. And then I want to know for which values of x would my original function have a max or a min. All derivatives are graphed in this negative 10 by 10 window, and we're only looking from negative 10 to 10. So we won't have intervals that go out to negative infinity or positive infinity. So this one, what makes it tough is people tend to want to read the information off of this graph as if these graphs were the graph of the original function. What we have to bear in mind is that these are actually graphs of the derivative. So I'm going to do it several ways so that you can kind of see different ways that you can look at it. The first way is to realize that derivatives of f prime, or excuse me, that graphs of f prime are in reality just sign charts that have more information attached. So we could treat this like a sign chart and look to see when the output of f prime is positive, when it's 0, when it's negative, when it's positive, and when it's negative again. So we can see that my original curve will rise, then fall, then rise, and then fall. So based on the sketch of f that we've just done, we can see that we have a max and a min, and then a max, and we've got mins on the endpoints. So we can say that we're increasing from negative 10 to 5, and then we increase again from 0 until 5. We can see that we're decreasing anytime f prime is underneath the x-axis, which is from negative 5 to 0. And then again from 5 to 10. We can see that we have minima here at my two endpoints, and then again at 0. And we can see that we have maxima at these coordinates, which were negative 5 and positive 5. Now notice that in the key I had soft brackets, and here I've got hard brackets. I don't care which you use because they're both viable depending on which book you learned your calculus from. So I'm pretty sure that they don't ding you for either notation on the AP exam. So now let's look at B and try and do it without graphing F. If we don't graph F, but we just look at what's going on with F prime, we can see that we are negative, then we're positive, and then we're negative. So that means f, the original function, will be increasing whenever f prime is positive. So that's going to be from negative 5 to 5. F will be decreasing whenever the graph of f prime is underneath the x-axis. So that happens from negative 10 to negative 5, and then again from positive 5 to positive 10. Minima, if you recall, occur when f prime changes from negative to positive. So we're going to have a min right here at x equals negative 5. Maxima occur when we have f prime changing from positive to negative. So that will be at x equals positive 5. Now the tricky pieces are looking at the endpoints. So we got to think about what's happening with the endpoints. My endpoint was 10 and my slope was negative. So that means I will start at a value and then go down. When I start and then head down, that means I had a max back here. So I'll have a max at negative 10. Here, this endpoint, I had a negative slope prior to the endpoint. So that meant I was falling until I hit the endpoint. So in that case, we'll get a min at the endpoint. Okay, using the same argument for B as we did, or excuse me, the same argument for C as we used on B, we can see that we've only got one sign change, and it's when we're changing from a positive to a negative. So that will be the location of a max. If we look at when f prime is above the x-axis, that's when the original curve will be increasing. If we look at when f prime is below the x-axis, that will be when f is decreasing. And if we think about our endpoints, here I have an endpoint at 10 and then I climb. That makes it a minimum at negative 10. Here I had an endpoint and I was falling while I got to it because f prime was negative, so that's going to be another minimum at positive 10.